Example, a passenger ship and an oil tanker left port at 7 a.m. The ship heads north at 40 miles per hour while the tanker heads east at 30 miles per hour. How fast is the distance between them changing at 9 a.m.? So they start at 7 and we want to know the change at 9, so that's 2 hours later. I'm going to go ahead and write my orientation, never eat sour watermelons. Okay, so the ship heads due north. So if the ship starts here, it heads due north. That's a vertical distance, so we'll say dy dt at 40 miles per hour. That's the direction of the ship. And the tanker heads due east, so that's a horizontal movement. So that would be dx dt. And it's traveling at 30 miles per hour. How fast is the distance between them changing? So what we're after is the rate of change of the hypotenuse. So that would be, what is dz dt? That's our end goal. Next, we need to write down all the given values and any variables that we have. For the ship, let's use the uniform distance formula. That's distance equals rate times time to get the distance 2 hours later. So that ship is traveling 40 miles per hour. 2 hours later, it's gone 80 miles. So the vertical distance would be 80. Y equals 80. Let's work with the tanker. How far has it gone in 2 hours? Distance is equal to rate times time. That is traveling at 30 miles per hour, goes 2 hours, so that's 60. So at exactly 2 hours later, it's traveled 60 miles. So x equals 60. What we need is z, that's that hypotenuse distance. So let's use the Pythagorean theorem. Z squared is equal to x squared plus y squared. When we solve for z, that'll be the square root of x squared plus y squared. Under the square root, x is 60 squared plus y is 80 squared. So we get that z is 100. So we know that the z is 100. We got a diagram, we got some parts. The next step is to construct or find an equation. We're working with a right triangle, so let's use the Pythagorean equation for a right triangle. That is the hypotenuse squared, z squared, is equal to the sum of the other two sides, x squared plus y squared. We need to implicitly differentiate that with respect to t. The derivative of z squared is 2z. Implicitly, we need to multiply that by dz dt. The derivative of x squared is 2x. Again, we're differentiating implicitly with respect to t, so we need to multiply by dx dt. Plus, and the derivative of y squared would be 2y, again, with respect to t, would be dy dt. 2 is a common constant, so they can factor out and cancel. And now we need to solve for what it is that we're looking for, which is the dz dt. That's going to be x times dx dt plus y times dy dt, all divided by z. Finally, we can take that derivative, dz dt, and replace it with the values. X, that was the distance of the tanker 2 hours later, and that was 60. Dx dt, it was traveling at 30 miles per hour. The y is the distance 2 hours later of the passenger ship, which was 80 miles, and it was going north at a rate of 40 miles per hour. The z, the distance we solved for, was 100. So compute that, and we find dz dt, that is the rate at which the ship and the tanker are traveling away from each other, is 50 miles per hour.